15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thanks for joining us on Space Nuts, the podcast about space science, astronomy, and all sorts of other stuff. On this week's program, episode 262, we'll be looking at the successful launch of Jeff Bezos into space. They put rockets on his feet, apparently. Astronomers have attained detailed images of a plasma jet from a supermassive black hole, and there are mountains on neutron stars. It's the size of them that will surprise you. Plus audience questions, one from Mark about buying a telescope for his son. I've got a sneaking suspicion it's not for his son. Mm-hmm. And Tyler in Canada wants to know why there isn't a telescope on Vancouver Island. Anyway, we will cover all of that. My name's Andrew Dunkley, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to see you. Good to talk to you. I should just check my levels as well. I think that looks as though it's all right. I'm not distorting. Just checking the view meter now. I've got one. You know, I have to use
Yes,
them.
Of course. You might as well use all the tools in the box.
The tools in the box, yeah.
Yes. Now, we've got more interesting times. The Delta strain continues to spread, and the town next door to us, the city of Orange, has been locked down along with its neighbouring shires because a couple of cases got into the region. It seems to be spreading via transport drivers, which is very scary. So, and that's how it got into Victoria. That's how it got into Queensland and South Australia, all through road transport. And the case that's shut down the city of Orange is apparently the story I've heard is that the driver was out of his vehicle and at the facility where the next person caught it from him for 90 seconds. Hmm. So if that doesn't tell you how easily this Delta strain is spread, nothing will. But, they're not taking any chances. A couple of cases have been recorded. We'll probably know more today as to whether or not it is spread in Orange. And between us and Orange, it's a very busy road interchange. The traffic between the two cities is significant. So we are on ready alert here. So fingers crossed. And you were at a hot spot, Fred, I believe.
That's right. Well, we've been
sicko?
We've been locked down in Sydney for 4 weeks now, and it's been full lockdown for basically a week and a half where you can't do anything. But one thing you're allowed to do is go to the shops to get your groceries. We did that on Saturday, and then were pinged yesterday because that shopping centre turned out to be a hotspot. So we were pinged as casual contacts, and if you're a casual contact, you have to get immediately tested and self-isolate until you get your results. And if it's within 5 days, you have to keep on self-isolating, even if your result is clear, and do another test. So we'll have to get tested again, which is why the interruption to normal service in terms of the recordings of Space Nuts. So this is a delayed recording, but hopefully all will be well.
But by the time people hear it, it'll be back on time.
We're masters of time lords. That's what we are.
Yes, that's exactly right. Spot on. Okay, let us begin. And another successful space tourist launch. Jeff Bezos made it into space, hung around for a while, took a few photos, and then came back down to Earth successfully. So Jeff Bezos and Richard Branson, only a handful of days apart, have made history. And it was a beautiful launch, wasn't it? It was amazing.
It was, yeah. Did you watch the live stream, Andrew?
I didn't watch the live stream. It was too late for me. You know, I get up at Sparrows.
Yes, you do. You get up. Yeah, that's right. I've got the luxury of.
I barely had my eyes open at 10 p.m. our time, so I so much wanted to, but I just couldn't. But I did watch it the next day on repeat. So
very good.
It was a great launch. They got up to Mark 3.
Yeah, they did. Yeah, which you have to do. So basically, the rocket kicks the capsule up to a speed of roughly 1 to 1.5 kilometers per second. So it's nothing like what you need to go into orbit, which is 8 kilometers per second horizontally. But still, it's pretty flashy. And I did watch it. It reminded me of many space launches I've watched because it had all the trimmings, the countdown. There was a hold in the countdown at 15 minutes just to check that everything was all right. And
check the tyre pressure.
Indeed, that's very important. But, it's nice to see the 4 astronauts boarding the capsule and their reaction when they came down afterwards. And that it actually, for me, is the special bit of this launch because it's not just Jeff Bezos himself, the world's richest man, but his brother Mark, who's a big fan of Jeff's, as you might expect, but also this lovely lady, Wally Funk, who, if I remember rightly, her real name is Mary, I think, Mary Wallace Funk, but she always got Wally. She's 82 years old, a role model for all us oldies, and she was one of the Mercury 13. So the Mercury 7, which many of us have heard of, were the 7 astronauts trained up for the Mercury program, which was right at the beginning of the United States' crewed space flight. And indeed, it was manned in those days because they were all men. The first missions as a precursor to Gemini and then to Apollo. But there was the Mercury 13, who were 13 female astronauts trained up to the same level, passed the same tests, had all the same attributes, and any one of them could have gone into space, but none of them did. So much for equality in the early 1960s. Wally Funk became a very big name in aviation. She was an accomplished fighter pilot. She kind of, did all the training, but gave up on ever going into space until Jeff Bezos came along and said, "I want you as the passenger on the first Blue Origin flight of the New Shepard spacecraft," which is what happened. And she was just thrilled. So she is now the oldest person to have gone into space because she crossed the Kármán line at 100 kilometers. That same flight also took the youngest person to have been into space.
That's right.
Because the story is an incredible story. There was an auction for the 4th seat on the mission. And the person who won the auction, the day before the flight was due to take place, said he was too busy. There's a headline I've seen. Winner of auction, $30 million, too busy to participate in the space flight. Anyway, that's all right. So they gave it to the next person down, and it turns out that this was a rather rich man in the Netherlands whose son is a pilot, a teenager, 18 years old. Yeah. He also flew. His name is Oliver Damon. And so it made history, the first ever commercial astronaut to purchase a ticket, and also the youngest person to fly in space. What a great story.
It's a great story. He might not have been first in terms of space tourism, but he certainly made a bigger exclamation mark.
Yeah.
Now, I've got a question, Fred.
Yes.
The two men involved in this, Jeff Bezos and Richard Branson, did it in very, very different ways. Yeah. Jeff did it with a rocket, straight up and down, and Richard did it with a space plane, basically, launched from the belly of a carrier. Yep. Which one would be the most fun? I'm thinking I'd like to go up in a rocket. I think that would be even one that looks as unsavory as Jeff's, but I think
don't go there, Andrew.
I couldn't help it.
Marnie said the same thing.
I think going up in a rocket would be the cool way to go.
I think you're probably right. Look, in an ideal world, we'd get to sample both, wouldn't we?
Yes, indeed.
The thing about the Virgin Galactic mode of operation is it's a much longer process. So I think the whole thing goes for about an hour and a half.
So you get more bang for your buck.
You do. You get this flight up to about 16 kilometres in a very unusual aircraft.
For want of a better term, I should have rephrased that.
Yeah, hanging underneath it. But then they drop the rocket plane. So you still get the rocket thing. You are shooting upwards at probably something like the same speed to get you up to 1 kilometre per second or thereabouts, and then glide back to Earth. So a totally different process. The new Blue Origin one is, as you said, it's a rocket. You sit on top of it in a capsule that's not that dissimilar from the the Apollo capsules or the Orion capsules, and then you come back on a parachute, because the rocket itself fully automatically lands on its own, the booster. Extraordinary technology that they've perfected.
It is.
And I think either of those will be a thrill. But, I lean towards the same as you, I think.
Yeah, I think the traditional rocket launches would be exciting. All right, well done to both, and another giant leap. Now, let's move on to our next story, Fred, and this one is exciting for a completely different reason. Detailed images of a plasma jet from a supermassive black hole. Now, we know about these plasma jets. We've had questions about plasma jets. To get an image, I think, would take it to a whole new level.
Indeed, that's right. And this is a story from an old friend of ours, the Event Horizon Telescope, which, of course, in 2019 captured the very first image of the event horizon of a supermassive black hole in the galaxy M87. You and I have talked about this before, and we kind of always suspect that there's much more going on in the background that this telescope has observed that we don't know about yet. And so now we do, because a new image has been released. I'm not sure when this image was, or there's several images, I think, but when they were made. But they reveal as you said, the plasma jet being emitted from the supermassive black hole at the center of a very well-known galaxy called Centaurus A, one of the first radio galaxies detected, which is why it's got an A. It's basically the relativistic flow coming from one of the poles of this black hole. And to put that into English, you and I have spoken before about the fact that, yes, black holes suck things in. So you get an accretion disk of material swirling around it, and that's what becomes visible in radio waves and infrared. But some of that stuff doesn't get sucked into the black hole. It gets refocused by the magnetic fields of the black hole to squirt out as a jet north and south, the north and south poles of the black hole, if I can put it that way, at relativistic velocities, which means nearly the speed of light. And so that is what has been imaged. Now, we see the effect of these jets, excuse me, when we look at radio images of what we call active galaxies. They're active in that their black holes are consuming material. And those jets sometimes extend hundreds of thousands of light years into space around the galaxy. So they're visible at great distances. But this is the first time we've seen one kind of as it's being emitted. It's the point at which it's squirting out. And what you see, it looks just like somebody's thrown down two sticks and lit them up or painted them orange and taken a photograph. But it's
that's what it looks like.
It's a cone of material, and it's probably a hollow cone. And that might mean that the black hole is precessing slightly, it's rotating, and the material is coming out in this conical shape, a hollow cone. So all you see is the edges. They're the bits that are lit up because the center itself is not luminous. So a remarkable image, absolutely extraordinary stuff, and a great achievement for the Event Horizon Telescope, which you'll remember is 8 radio observatories in the western hemisphere of our planet, and they all work together to basically to be able to resolve detail on the scale of a pea on the moon. To quote what the author of it's Gemma Conroy, actually, who wrote a very nice piece on this on the Australian ABC News website. I think she described it as the level of being able to see a pea on the moon, which is about right. It's very, very fine detail. You and I are both looking forward to what comes next from them, which we hope will be
something.
The black hole in the center of our own galaxy.
Of course, Sagittarius A star.
A star, that's right. Yeah,
I got there eventually.
You did, yeah. No, look, it's. I'm sure they've observed that already. They're probably still doing the number crunching because there's an extraordinary amount of work needed for that.
I can imagine the computer power required would be astronomical.
Oh, that's a good word.
It is. You did answer a question when you were explaining these plasma jets that I didn't even know I should have asked, but I always assumed that the stuff that went into the black hole was what was being blasted out. But you said that it's the stuff that doesn't go into the black hole that's being ejected.
Yeah, because the stuff that goes into the black hole is the point of no return. Once they cross the event horizon, you've had it. And so this is a sort of curious, and I confess I don't really understand the mechanisms of this because I'm not an expert in magnetohydrodynamics, which is what it's all about. Not an expert in anything, really. I did used to know a lot about telescopes when I was in charge of a big one.
But then Galileo stole your thunder, didn't he?
He was a good lad, was Galileo. I remember him well. So the hydrodynamics of it are probably pretty complicated, but essentially stuff gets bypassed. It bypasses the black hole itself because it suggests that these magnetic forces are enough to disrupt or to overcome the gravitational force, which is what is absolutely the number one force in the region of a black hole. But the magnetism, the magnetic forces, or electromagnetic forces, they are really, they actually can refocus the material, squirt it out in a term we call collimated, which means it's all going in effectively a parallel beam, although slightly conical, as we've seen.
So that's how you avoid being sucked into a black hole. You make yourself a suit of ever-ready batteries.
And take a strong magnet with you as well.
Exactly.
That'll help, I'm sure.
Just put it all together. I think that'll solve it, yes. All right, very exciting news and more to come, obviously.
Yeah.
This is the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
And thanks for joining us on episode 262. And if you would like to help us out a bit, you can do that by becoming a patron. And by becoming a patron, you get bonus options. Now, one of the things we're working on is special editions of the YouTube version of Space Nuts for patrons. So you can take a look into that. You may have already received a notification from Hugh as to how to access that as a patron. Now, that's just one thing we're working on to say thank you to the people who pay us a couple of dollars a month just because they want to, and keep the podcast alive. So if you would like to look into becoming a patron, you can do that via our website, spacenutspodcast.com, and then click on the supporter button, and all the information's there. And thanks again to our patrons. But yes, we're looking at all sorts of different ways to say thank you and give you extras as a part of the package of being a patron. So thank you again for your ongoing support. We've got so many patrons now. I've forgotten all their names, Fred. So, but we know who they are. They sometimes send us questions. But yes, they're fabulous people. In fact, all our listeners are fabulous people. So we really do appreciate the support in whatever form. Now, let's move on to our next story. And this one I find extraordinary. We've talked about neutron stars, and I guess we should probably revisit what a neutron star is before we talk about the mountain ranges that exist on neutron stars. Now, I as I read through this, it got more and more extraordinary. When you talk mountain, you're thinking huge obelisks of stone, and of course that wouldn't be the case on a neutron star, but they do have mountain features, just really not quite big ones. It's bizarre.
Exactly. It is, isn't it? And I think this is a great story. And it once again, it shows the power of the theoretical physics that goes into understanding things like neutron stars. So what's a neutron star? It's in some ways it's related to black holes because when a massive star gets to the end of its life, if it's massive enough, if it is big enough, it will explode in a supernova. Its core will collapse, and if that core is big enough, it will overcome every known force of nature and collapse to become a black hole. But there's a kind of intermediate stage for smaller, less massive stars, maybe 10, 20 times the mass of the sun when they start. Their core collapses, and if it's less than, I think it's 2.2 times the mass of the sun, the mass of the core. If it's less than that, it will collapse until the pressure of neutrons, the outward pressure of neutrons, actually stops it collapsing any further. So it's on its way to being a black hole, but not quite big enough to do that. And that's how we think neutron stars are formed. There are many, many of them known. Once again, they have very strong magnetism and beam out radiation from their poles, like the sort of thing we've just been talking about. But if they're rotating, these beams of radiation sweep through the universe. And if the Earth happens to be in line of one of those, you get this effect just like a lighthouse rotating. And we call them pulsars. That's what a pulsar is. It's a rotating neutron star. So that much is all known. We know they exist because they were discovered back in 1967 by Jocelyn Bell Burnell, who I'm delighted to say is a friend and former colleague of mine up in the UK. We used to work together at the Royal Observatory in Edinburgh. Anyway, it was actually Jocelyn's work that not only proved that neutron stars exist, but also led to people believing that black holes could exist, because until then they were perfectly theoretical. Anyway, that is all the backstory. What's the front story? It is that researchers have looked at the structure of neutron stars, and neutron stars having magnetism sounds a bit weird because neutrons are electromagnetically neutral. So that we know that there is a mixture in there, which includes protons, which are electrically charged. And in fact, I think some of the thinking is that these neutron stars have a crust of different sort of material around the edge, quite a thin crust, but relatively rigid. I didn't explain, by the way, that a neutron star is typically 10 to 20 kilometers in diameter and contains the mass of a star, up to 2.2 times the mass of the sun. So the density is in the region of 1 billion tons per teaspoonful.
Good grief.
That sort of density. Yeah, it's crazy stuff. And that means that the gravitational pull at the surface of one of these things is about 1 billion times what we experience here on Earth. So
you'd be quite small if you went there.
You would be quite small, as are the mountains. That's the critical part. It's that gravitation that stops this crust having bumps in it bigger than a few tenths of a millimeter.
Wow.
I know. It's madness, isn't it? So you've got this ball 10 kilometers in diameter and little dimples on it that you can barely see because they're so small. And so what it means is that neutron stars, I think it's probably the case that they have seized the record, theoretically at least, as the most perfectly spherical bodies in nature. That record has previously been held by, any guesses?
Oh, gosh. Black holes?
That's a good guess, actually. You might be right, too. But it's not. The one I'm thinking of is the sun. The sun is...
Of course. I knew that.
Incredibly, perfectly spherical. Yeah, sorry.
Yeah.
I'll put you on the spot twice today. So,
no, I'd heard that before, and it just, usually my brain doesn't let me down like that.
Mine always lets me down like that. Yeah, so the sun, for all its 1.39 million kilometers? I think that's right, in diameter. The biggest departure from a sphere is 10 kilometers, which is just amazing. That's 1 part in 100,000 or something. It's just phenomenal.
Yeah, compared to the Earth, because we bulge because of our rotation, our spin.
That's right.
Yeah,
and the spin of the sun is quite slow. That's why, that's probably why it's so spherical. It's 25 days on the equator. It's different at the poles because it's not a solid body. So it looks as though neutron stars take the biscuit in terms of being perfectly spherical. Or maybe perfectly smooth is a better way of putting it, because I guess they could still bulge at their equator.
They're the billiard balls of space.
Yeah, Yep. It's funny how we all think of billiard balls, but that's basically it. That's very smooth.
I don't know why.
No, I think of that as well.
Yeah. Funny. Oh, I was just looking at your head. Sorry.
That's actually quite smooth too. It's within one part.
Yeah,
one part in 1,000, probably.
you could have neutron star properties there, Fred. I think. Yeah. Perfect roundness.
Actually, the main neutron star property is that it's very dense inside. Totally dense brain. Yeah.
No one can accuse you of being dense, Fred. I've been called that a few times by teachers at school. But,
oh dear, I've been called worse than that, I can tell you.
Haven't we all? Yes. Oh dear. Glad those days are gone. Okay, so mountain ranges on neutron stars are minuscule. Minuscule, we'll call them that. Right. So you won't trip over them. But then again, if you do ever travel to a neutron star, you'll end up being smaller than the mountains, I would imagine. Yeah. Due to the gravitational forces.
I suspect as you got near it, you'd be spaghettified like you would with a black hole because the gravitational potential is so intense. Yeah.
Unless you're wearing that suit we were designing.
Course, yes, in which case
with
you get
magnets
shot out with
and never ready batteries. You're right then. Okay. This is the Space Nuts podcast, episode 262. Andrew Dunkley here with Fred Watson.
Space Nuts.
Okay, Fred, time to answer some questions. And the first one comes from, not far from you. This is in Sydney.
Hi, Andrew and Fred. It's Mark here from Sydney. Thanks for the great show. A quick question around telescopes. My son is turning 7 in a couple of months, and I've promised him that I'm going to get him a telescope. However, I might have seeded that idea a bit because I also want to get a telescope. I'm interested in what your thoughts are of what I should be looking for, something that's easy for him to use, but also something that I can use as well. And I'm looking at spending around 500 Aussie dollars. So if there's anything that you could recommend or give me some advice on that, I'd be most appreciative. Thanks, guys.
Thank you, Mark. I love the way you think. It's for my son. But, I'm going to use it too. I'm doing the same thing. I'm buying my boys a telescope for Christmas, which will be here, and they all live away. So I know where you're coming from, Mark. We've had the question a couple of times before, Fred, in regards to, what should I buy? This is my budget. What's out there? This is what I want to achieve. And it does come down to what you want to do with it a lot of the time.
It does. Yes.
You've got to know where you want to point it and what you want to look at before you can really choose what telescope you need to get.
That's right. And it depends. I mean, you've made the point, but it depends on how much you know about astronomy, how familiar you are with the sky. Can you find your way around the sky among the constellations?
My familiarity is, I think I might look at that thing.
So that's good because that's most people's view of it. Which is, in some ways, it's a tragedy because if you and I had been having this conversation a couple of 100 years ago, everybody would have known where the constellations are because there wasn't anything else to do at night. You go and look at the moon, look at the stars, work it all out. Yeah. So a lot depends. I mean, the worst kind of telescope is the one that stays locked up in a cupboard that never gets used. Yes. So what you want is something that is going to fit the bill in terms of being fun to use and easy to use and letting you, get reasonable views of whatever you want to look at. $500 is a good amount, actually. You can do very well. And there are several different kinds of telescopes, all of which would fall into that price range. Probably the most straightforward and certainly the most foolproof in the sense that there's really nothing to go wrong is a Dobsonian. And that is it's a reflecting telescope. That means it's got a mirror rather than a lens to focus the light. And its style is the same as was invented by Newton in 1668, I think it was. He showed it to the Royal Society, which has a little mirror to bring the light out the side of the tube, so your head's not in the way as you look at the mirror. It's got the big mirror down at the bottom and then a small diagonal mirror to send the light out of the tube to the eyepiece, and you can put different eyepieces in to give you different magnifications. Now, the thing about a Dobsonian is it's on a very, very simple mounting. It's basically a box with pivots on it, so the telescope can move up and down. And then the whole thing is on a Teflon bearing, so you can easily move it around. And you just move it around by hand. It usually would have a finder telescope on it, which is exactly as the name suggests, something that lets you find things. It's a low magnification, usually about 7 or 8 times, with a crosswire in the middle, so you can check what it is you're trying to find. And they're great for looking at the planets and the moon. And all the sort of things that you immediately think about you want to look at with a telescope. But they're also good for star clusters and more distant objects. You can, if you get really hooked and you've got dark skies, that's the other critical thing. Now, Mark's in Sydney, so he's got to put the telescope in the back of the car and take it somewhere else to get dark skies. But you can see galaxies and things of that sort. And you would get a good one for $500. What it won't let you do is take deep sky images. So you could certainly, using your smartphone, you can actually put the thing on the eyepiece and take a picture of Jupiter or whatever it is. That actually works quite well. But to get these, if you want to develop into a hobby where you're really seriously looking at deep sky images, you need a different kind of telescope with a different sort of mounting on it. So if I may just add one more thing. There are 2 basic kinds of telescopes: reflectors, which use the mirror to form the image; refractors, which use a lens, and are much more like what we think of as a telescope, a lens at one end and another at the other, called the eyepiece that you look into. At the entry level, there are some really good little refractors as well. Come on a tripod. They've usually got twiddly knobs so that you can set them on the object that you're looking at. But the latest ones also have a facility that lets you use your phone to find your target objects, and it's really clever. And in
fact, some of them you can mount the mobile phone on the telescope.
On the telescope, that's exactly what I mean. Yeah, you mount it on the telescope, and you basically push it to where. So the mobile phone shows you what you're looking at, what it's pointing towards, and if you type in an object that you want to look at, it'll give you a little arrow on the screen that tells you which way to move the telescope until it's in the field of view. It's amazing stuff. I'm not sure what sort of price range they are, but I think you would get a decent one of those for $500 as well.
Now, Mark, by coincidence, and I'm serious, this is a coincidence, Space Nuts has attained a new sponsor this week that just happens to be a company that sells telescopes. I'm not joking. It's only just been stitched up, this deal. And if you would like to, search their website, we have a special URL available where you can basically go in and choose what you are looking for in terms of the type of telescope or binoculars that you want. It's got a product wizard built into it, and so you just sort of answer a bunch of questions, and it'll sort of whittle down what's available in the parameters that you set, and say, okay, these are the telescopes we recommend. Price wise, a lot of these are well under $500, and they're really good telescopes. The company I'm talking about is Orion Telescopes and Binoculars. Now, if you'd like to just pop in and have a look, the URL is very simple. It's spacenutspodcast.com/telescope. There you are. So take a look, and you might find what you're looking for there. I'm sure you will. They've got a vast array of product. spacenutspodcast.com/telescope. I told Hugh I'd be really subtle about it, so there you are. Now, let's move on. And thanks again for the question, Mark. And I hope, your son's going to be a very happy man, or boy, if he can get it from you at some stage. Let's move on to a question out of British Columbia.
Hello again, Space Nuts. It's Tyler Lucan here from the humble village of Bowser, British Columbia on Vancouver Island, Canada. Got another question for you. I remember from a previous episode you discussed the advantages of telescopes or observatories on the west coast of continents, landmasses, etc., but for what reason I can't quite remember. Obviously by the fact that there are several great telescopes on the coast of South America, earlier ones in California, Canary Islands, etc., it must hold true for some reason. But my main question is, why don't we have one here in Canada on my beautiful Vancouver Island? We are on the west coast of the continent, and additionally, on the west coast of this island are some absolutely perfect, beautiful mountains that you can put a big, huge telescope smack dab on top of out of cloud cover. So how come there aren't any there? Wouldn't a large northern hemisphere observatory be good for science? The closest telescope I know of, which is not actually an optical telescope, is CHIME on the mainland British Columbia, which is about 500 kilometers as the Canada Goose flies. But I put this question to you. Now, if this question does make sense, can I suggest that Space Nuts team start a crowdfund and we call it the Space Nuts Optical Observatory Program, or SNOOP? Because I know how big of a struggle it is creating decent acronyms are for serious astronomers. Sincerely, your dedicated T-shirt wearing fan since episode 1, Tyler Lucan from Bowser, British Columbia, Canada, on beautiful Vancouver Island.
Oh, dear. That was wonderful, Tyler. Thank you so much. Snoop, I like the idea of that. Snoop. That's a great name for a
fantastic.
telescope.
Yeah, I think Snoop's a perfect one. We really need to use that. Tyler, your question was great.
Yeah, awesome. Yeah, so why isn't there a decent international or intergalactic standard telescope in that region, Fred?
Well, there is this CHIME, as Tyler mentioned, which is, of course, a radio telescope and doing great work, by the way. Fantastic stuff up there in British Columbia, especially in the search for fast radio bursts. CHIME is the standout star at the moment. However, optically speaking, Canada does have some great observatories. The David Dunlap Observatory, I remember reading about that when I was a kid. But it's like many northern cities or regions, it does not have the right kind of geography, and particularly in terms of climate. So it's at a latitude that is comparable with the UK, actually. It's 49.7 degrees, Vancouver Island's latitude north. And that puts it in a climatic region that we now know is not worth building a big telescope in, because there's basically too much moisture there. Vancouver Island, I have to say, I'm ashamed that I've never visited, but my wife used to live not far away. She lived in Vancouver for quite a while. And
I was actually supposed to be there round about now.
I remember that
something got in the way.
And it's something we don't talk about much. But I know it's a very, very beautiful place. And when you look at photographs, you see these beautiful wooded hills and mountains. And that basically is the first hint that it's not the right place to build an observatory. Because when you look at the best optical observatory sites in the world, you're looking at Mauna Kea on Hawaii, you're looking at Cerro Paranal in Chile, you're looking at the Roque de los Muchachos in the Canary Islands. These are bare mountains. They have single figure humidity when it's really damp, and otherwise the humidity is zero. And that's because of the zone in which they are situated, usually between about 20 degrees and 40 degrees of latitude, either north or south of the equator. That also plays into the amount of dark time you get. The first published paper I wrote back in 1970-something was on the variation of darkness with latitude. And it turns out that you get more hours of darkness if you're between 20 and 40 degrees latitude. So you win out on that. But the main thing is climatic. You need that dry zone. It's absolutely right. It's got to be on the western seaboard of a continent. But you need conditions that are generally less moist than you have up at 49 degrees latitude. And the other thing that Vancouver Island doesn't have, because I just checked, its maximum height is 2,200 meters, thereabouts. You really need to be above 3,500 meters to get the effect of these perfect conditions. So even thinking of mainland USA, the western states, they're down in California. Some of the great telescopes of the 30s and 40s were built there, or 20s, 30s, and 40s even the 10s, 30s and 40s, because the Mount Wilson Observatory was built at the turn of the century. Those are places which did fabulous work, but today we wouldn't put a telescope there because they're not as perfect as you want. You want absolute perfection if you're going to spend $150 million on building a big new telescope. So it's all about geography. We in Australia are in the same boat. We don't have a mountain high enough. We've got mountains that are roughly the same height as Vancouver Island, in fact, but they're in the wrong place. And so, they're covered in snow, they're often cloudy, and it doesn't work. So I'm really sorry, because I love the idea of Snoop.
Yes.
We might have to ask Kyla to license the name to us for some other optical telescope that starts with space nuts, which I love.
I'm sure he'll be fine with it. But too bad, Tyler. Vancouver Island, a beautiful and amazing place, but not telescopically advantaged.
In terms of spending a lot of money to build a very big telescope. And, that's right. These days, it's basically Hawaii, La Palma, or Chile, or, in fact, South Africa has also got some good sites. Yeah.
Okay. But love the question, Tyler. Thanks very much. And hello to your dog, who I think interrupted.
By the way, Bowser's a lovely spot. I looked it up on the web. Yeah, it looks great.
Yeah, terrific. All right. Appreciate that, Tyler. Thank you. And thanks again to Mark for sending in those questions. Don't forget, if you have a question for us, you can send it to us via our website, spacenutspodcast.com. and click on the AMA link where you can send us a question via our email interface, or you can upload an audio question. Just don't forget to tell us who you are and where you're from. We love to know about our Space Nuts audience. So, yes. But, spacenutspodcast.com and click on the AMA tab. And while you're there, check out the Space Nuts shop, of course. Lots of goodies there. We're adding new products all the time, so pop in and check them out. Given the heat of the Northern Hemisphere at the moment, a pair of flip-flops would be the go, in my humble opinion, with the Space Nuts logo on them. Fred, that brings us to the end of yet another episode. Thank you so much, sir.
Great pleasure, sir. Good to talk to you too, and we'll speak again soon.
We will indeed. Professor Fred Watson, astronomer at large, part of the team here at the Space Nuts podcast, and thanks again to Hugh in the studio. It's just a closet, actually, but he likes to call it a studio. Just got to make him feel good. And for putting all the bits and pieces together and getting it out there on all our podcast platforms. And from me, Andrew Dunkley, thanks again for listening. We'll catch you again on the very next episode.
Space Nuts. You've been listening to the Space Nuts podcast. Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Sites.com.